So in this session, we'll be figuring out the key concepts. We'll be figuring out the derivations which are required to be practiced, right? And the marking scheme, right? What these chapters, how many marks these chapters have in the final exam, right? This all we'll be discussing. So let me share with you the presentation, right? Then we'll be starting with the session. So if the participants can turn on their cameras, it would be an effective session for you people also, and we can be interactive. I hope your preparation is going very fine, right? So now as the last phase of the preparation is going on, so you need to be very consistent, right? And be very thorough with your revision, right? And practice as much as you can. The previous year questions, we have been focusing about this point since the previous webinars, right? So you should be focusing on practicing previous year questions, previous year papers, at least of the last 5 years. So let me just share with you the presentation. Is it visible? Can anyone tell me? Is it visible to you? All right, thank you, Sanika. So you see here, so we are discussing, we will discuss today these topics, right? This moving charges, magnetism, and EMI, right? Moving charges and magnetism, and in magnetism only I'll be discussing this magnetism and matter, right? Very short topic. This is right. We'll be discussing about the marking scheme also, right? So let's move ahead. So you see here, so as we have been doing since the previous sessions also, so we'll be covering the, so I'll be sharing with you another presentation which will be discussing these concepts, right? Which will be having a recap kind of notes, right? So the team will be sharing with you that also. So in moving charge in magnetism, right? It's quite a long chapter, right? You must have also analyzed it that it's quite a long chapter we have. What are the important points what are the important concepts that we need to cover in this chapter are first about the magnetic force in itself, right? So magnetic force. So magnetic force on what? Magnetic force. So two points here we have, right? Magnetic force on a moving charged particle. Right. So magnetic force will be in a magnetic field, right? So on what? On a moving charged particle. Right. And another magnetic force that you need to learn is about what? About the force on a current carrying wire. Right. Current carrying conductor or wire. So can anyone tell me about the force on a current carrying conductor of, let's say, a length L. Let's say I have this conductor and it is of length L, right? And it is in this magnetic field region of magnetic field B, right? And it is having this current I. So what do you think would be the current? What do you think would be the magnetic force on this wire? Can you tell me? Would there be a magnetic force or not? What would be the magnetic force? What is the formula for that? Do you remember? Anyone? So it should be ILB, right? So this is the important formula. ILB, right? How do we denote it? It is in the vector form. It is written as vector FB is equal to I vector L cross vector B. Remember, right? So the force would be in which direction? Can you tell me? And what is the direction of vector L here? The direction of vector L would be in the direction of the current. So this is the direction of vector L. So vector L cross vector B. So what is the direction of force? Right. So direction of force would be in this direction. It will experience a force in this direction. Right. Right. So this concept, current carrying conductor and the moving charged particle one. Right. So what is the formula for moving charged particle? If I have, let's say, a charged particle Q and it is moving with some velocity V in a magnetic field, let's say B, what do you think? What do you think is the force on it? Yes. Right. Good. Good, Jasim. It is QVB sine theta, right? So what is the formula for it? Vector FB is equal to Q vector V cross vector B. Can you tell me the direction? What should be the direction here? Can you tell me the direction? So you see, vector V, we use the right hand rule, right? So vector V, first vector, right hand along the first vector, curling the fingers around the second vector, it is into the plane. Then the direction of the thumb will give the direction of the force. So the force would be in this direction, right? And if the force is in this direction, what do you think? What kind of motion it will be having? Right, good, Jasim. It is upwards. So what would be the path it is having? Right, it is having a circular path. Right, good. Right, so it must be having a circular path. Right? Can you tell me what should be the radius of that circle? Very important formula. What should be the radius of that circle? These all things you should be. Great, Shah. Great, Jasim. It is mv by qb. Right? This is the radius of the circular path. So these two concepts related to magnetic force are important. That magnetic force on a moving charged particle, a single charged particle, and the magnetic force on a current carrying conductor. Right? All right. Then we have this concept of Biot-Savart law, right? The chapter starts with this Biot-Savart law, right? What it tells us? It tells us how to calculate magnetic field due to a current carrying element, right? That it shows that if you have a current carrying element, so this is analogous to which law? This is analogous to the Coulomb's law we have in electrostatics, right? In electrostatics, due to a point charge, what we calculate the electric field. Here, due to a current element, right? It is only due to a current element, I vector dl. So this is known as the current element. So due to this current element, what would be the magnetic field? What would be its strength? Because magnetic field is a vector quantity, and what would be its direction? That will be told by the Biot-Savart law, right? And then the other important part here is the Ampere's law, right? Can you tell me the Ampere's law? What is Ampere's law? What it tells? It tells the vector B dot vector DL, right? It tells something about this, right? The dot product of the magnetic field and the DL, right? So it tells you what? Like,
Integration of magnetic field around a closed loop.
right around a closed loop, it tells you. So what it is equal to? It is equal to the net current,
You
that
not
net current, like mu naught into the net current, I net passing through the loop, right? That it tells you, right? So you understand that? No. So let's suppose I have this loop. Can I have this loop? Any random loop I can have, right? I can have any random loop. So let's say I have this loop, right? And I have this loop, and I have few currents passing through it, right? Let's say one is this current, I1. One is this current. Let's take some example, right? Let's have some values here, right? So let's say this is 5 ampere. Let's say this is 2 ampere, right? This is coming out of this is going into the plane. So what do you think would be the I net? Can you tell? What should be the I net? What should I put the value here? If there's a loop, right? So it should be 3 ampere, because one current is going into the plane, one current is going outside the plane. And what do you think the magnetic field would be in which direction? It should be clockwise or anti-clockwise? Because the net current is into 3 ampere is into, right? So magnetic field would be like this. It should be along this direction, right? So this thing calculates what? The value of this, right? Let's take a DL here. So we take some DL here, vector DL, right? Then we calculate what? We calculate the magnetic field associated with it, right? We calculate, let's say the magnetic field at this point can be like this also, right? And then we calculated their dot product. We calculate vector B dot vector DL. Similarly, we do this here. We take some DL, right? Let's say we have some magnetic field here, then we do its dot product, and then we sum it all around the entire loop. And that would be equal to the mu naught into the net current passing through the loop. Got it? So this is Ampere's law. So Ampere's law statement is important, that might come, right? Right, then we have other related topics. And also, please let me know, I'll be sharing with you this syllabus also. So there is MCG or not? Moving coil galvanometer is also there or not? What do you think?
Yes, sir.
Yes, it is also there, right? So moving coil galvanometer also gets you questions in the form of converting galvanometer into ammeter or voltmeter, right? One of the questions will be from here, and one of the questions from MCG, right? All right.
Sir, about the torque also.
About the torque also, right? About the torque also, right? The magnetic moment concept, right? Vector M cross vector B. Vector M is what? The magnetic moment. That I'll be sharing with your presentation also with that. What is magnetic moment? Can you tell me what is magnetic moment? What is magnetic moment? Magnetic moment of a loop. Can you tell me?
It is a product of the strength and the length between the conductor.
No. Current and area of the loop. Good, good, good. Very good. Very good, Jasim. Your revision is going very good, Jasim, I think. Right? Great. So moment is current into area of the loop, right? Got it? So let's say I have a circular loop, right? I have a circular loop having radius r, and a current I is going through it. So what is the magnetic moment of it? Can you tell what is the magnetic moment of it? Its magnetic moment is current into the area of the loop. What is the area of the loop here? Pi r square. Got it? Right. Good. Good, Justin. Right. I into pi r square. And what is the direction of the magnetic moment here? And so we use the right hand rule, right hand thumb rule. So we curl our fingers along the current direction of the thumb will give the direction of the magnetic moment. So it is into the plane here, right? It is into the plane here, the direction of the magnetic moment. Got it? All right. So then we get into this magnetism and matter, right? So this magnetism and matter, earlier there was Earth's magnetism also, but it's great for you that it has been deleted now, right? Because it seems complex to many students, right? So magnetism and matter, we have only two concepts, right? One is related to the bar magnet, the magnetic dipoles, right? So this whole topic is related to bar magnet, because bar magnet is the magnetic dipole only, right? So you'll be learning about as similarly as you have learnt about the electric field due to electric dipole. So this is very important from the derivation point of view, right? Bar magnet wala part. So in electric dipole, as you find the electric field on the axial line on the equatorial point, similarly you will find the magnetic field due to a magnetic dipole at the axial point and at the equatorial point, right? And same kind of formula will come, right? And what are the field lines, magnetic field lines of the bar magnet, that can also be asked for you to draw it, right? Then we have magnetic properties of substances, various substances, right? So we have diamagnetic, so you need to study these diamagnetic substances, paramagnetic substances, and ferromagnetic substances, right? And how do they behave in response to external magnetic fields, right? When these substances are placed in a magnetic field, how these substances behave. So that will tell us the magnetic properties of them. So that we'll have to study only in this chapter. Very scoring topic this is, right? Very scoring. Only theoretical concept is more, right? So you see, in this moving charge and magnetism also, there is not very lengthy kind of any derivation, right? But there are different concepts. For example, Ampere's law statement, it may ask you the Biot-Savart laws statement, right? It may ask you the force between two parallelly placed conductors. That is a very typical question which CBSE asks like every year. Force between two parallel current carrying conductors. You get it, right? Let's say we have two conductors and they are placed at a distance d. One is having current I1, one is having current I2. So they'll be having a force between them, right? So you need to calculate that. So that type of questions might come. And in magnetism and matter, they may ask you the bar magnet kind of the calculation of magnetic field, at axial point, that I mentioned in the presentation also, that I'll be sharing with you, at axial and equatorial points, at axial and equatorial points, right? That you need to find for large instances, like the way we do in the case of electric dipoles, no? At axial point and at the axial point, what do we get? We get 2 k p, right? Vector p by r cube. This kind of formula we get, right? You understand this, no? Where r is very much greater than the separation between the length of the dipole. When r is very much greater, so this kind of formula you will get here also, right? Then we have electromagnetic induction, right? It's a short topic, it's a short chapter, but a uh, very important one, right? Yes, Jasim, it's similar to electric dipole. So in electromagnetic induction we have two laws, so they might ask you the statements of them. So you should be knowing that, right? In electromagnetic induction we have two laws. One is Faraday's law, one is Lenz's law, right? What Faraday's law tells you? Faraday's law tells you the magnitude of the EMF, right? The magnitude of the induced EMF. So EMF induced, right? We write it like this. So induced EMF, what is the formula? Can you tell me? Minus d phi b by dt, the rate of negative of the rate of change of flux, right? So it will give you this thing. Faraday's law gives you this thing. What Lenz's law tells you? Lenz's law tells you the direction of the EMF, right? It tells you the direction of the EMF. that the EMF will be induced to oppose the change, right? The direction of the induced current is such that it opposes the change producing it, right? So it is, so which principle, it may ask you in MCQs, right? Which principle this Lenz's law is based upon? So it is based upon the principle of conservation of energy, right? For it's MCQ, this question might come. And on which conservation principle this Lenz's law is based upon? So it is based upon the conservation of energy, right? I think you are getting it. All right. Then we have this concept of self-inductance, right? So self-inductance, what is self-inductance, right? For example, you must be knowing phi is equal to Li, right? So this is the main equation for the self-inductance. Phi is equal to Li. So what it is? It is self-inductance is the a coil, when a coil opposes changes in its own current, right? For example, a coil is having current and we change the current, then the EMF is induced in that very coil only, right? So that is self-inductance. And one concept is also there, which is mutual inductance. Mutual inductance, right? So sometimes they ask you what? They ask you the self-inductance of solenoid. Self-inductance of solenoid, they may ask. Right? What is the formula of it? That it may ask you. And also from the mutual inductance part also, they generally ask the solenoid related questions. Got it? And one thing is also there. Yes, yes, we have Curie's law also. So that comes under the ferromagnetic paramagnetic part only. Right? Yes, we have Curie's law also. That is important, right? Curie's law. Can you tell what is Curie's law? Anyone? 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 Yes. Can anyone tell? I don't think anyone has turned on their cameras. No one has turned on their cameras. Tell me. Yes, susceptibility, I'm not asking. I'm just asking the main concept between what is Curie temperature? Tell me what is Curie temperature? What is that temperature means?
Yes, you need that kind of a empathy कि हाँ ये बंदा मुझे लेके जाएगा. तो इसलिए मैं कहता हूँ टीचर्स को ना जब भी मतलब किसी आइसटेक एग्जाम के लिए भगवान मान लो उस टाइम पे उनको.
Can you tell?
ठीक है, चाहे टीचर कितना भी बता दो. हाँ, of course पहली बार में.
All right, so we'll be discussing that, right? Curie temperature is the temperature at which what happens? Some change takes place, right? A material gets into some different magnetic property. That we'll be discussing. All right. So then, yes.
Because science is same for all of us, right? It cannot be different, right? Social studies, social studies.
Yes, Janam. Janam. Yes, you're correct. The temperature at which the ferromagnetic starts to behave as paramagnetic, right? Felsia, not the opposite one. It is not paramagnetic, does not convert into ferromagnetic. Ferromagnetic gets converted into paramagnetic on increasing the temperature, right? So that is that temperature when that conversion takes place, right?
So then I thought
all right. So chapter wise weightage, we will see that. So you see here, paramagnetic. Right. Yeah, great. Good, Jan. So you see, moving charges, we have how many marks? This moving charges is of, I think, will not get it here. So this moving charges come under 6 marks, right? 6 marks questions. So you may expect a question in 5 marker also from moving charges, and 1 question in MCQ, right? Or you might have this paragraph case study type of question from moving charges, right? So moving charges get 6 marks. Magnetism and matter gets 5 marks. Right, 5 marks this magnetism matter gets. So you should expect 1 question from the bar magnet and 1 question from the magnetic properties, right? And then this EMI has this 4 marks weightage in the entire paper, right? So 6, 5, 4. So how many of these 3 topics combined will be having 15 marks,
but हाँ उस time क्या था, what was the case
right?
at that
15
time?
marks in the entire
Because you were your body did not
paper
realize
will
that
be having,
happening.
right?
Realizing it happening.
So you see, I have been telling you this repeatedly that while doing previous year papers, do the analysis also, right? So it should not be that you will keep on analyzing only, just do it and just see what common question types, right? You should see that some questions you might be observing that they are repeating. So if you'll solve 5-year papers, no, just solve 5-year papers, I'm telling you, and just analyze them. You will be very relieved because you will see that many questions get repeated, or the pattern of questions or the type of questions are getting repeated. Right? So you'll be getting numerical problems, obviously. So as I have told you, numerical problems you'll get derivations, you'll get theoretical questions. Right? So you start to learn about the recurring themes which are coming, right? For example, this magnetic properties, the questions are always coming. So what kind of questions are coming? Like Curie temperature questions are always coming, right? For example, moving coil galvanometer questions are always coming, right? So this type of analysis you will have, right? It's not that you should be very much wasting your time on the analysis part. Just you will automatically you'll feel that, right? It's happening, right? Okay. Then let me tell you the strategic revision techniques, right? So you should have entire focus on the NCRT, right? I am making this presentation not just from this point of view. Every presentation I'm telling you these techniques, these things, right? So NCRT focus, very important. You should not like deviate now at this point of time to other books, right? You should not have this tendency, right? So review all the concepts, and I'll telling you I have written it also here that solved examples are very important. Solved examples from NCRT, right? Instead of going for other books, instead of going for other mock tests or something, solved examples, right? Thoroughly, right? Then we have this concept mapping, right? You can also try to relate, just say, as I have told you that the bar magnetic field is analogous to the electric dipole electric field that we calculate. So that kind of thing, because it would be easier for you to remember them, right? And last but not the least, problem solving. Practice as much numericals as you can and derivations. You practice your numerical problems and derivations, right? Theoretical part, the statements must be ready with you. The Biot-Savart law, what is because these questions will be asked about the Ampere's law statement, Biot-Savart law statement, right? Faraday's law, right? Lenz's law, all the statements should be ready with you, and the derivations and the numericals. Only these three things are there, right? So, lastly, you should be reviewing your notes, right? Very thoroughly, you should be reviewing your notes, whatever notes you have from your school, right? From your coachings, from your any other help, which you have prepared till now. Now is not the time to prepare notes. The notes you have now. So those notes you must revise, right? Solve previous year papers, very, very important. Yesterday also I told you that 5 years would be sufficient. 5 years you solve, right? The latest is 2024. No, you solve from 2020 to 2024, right? This target you keep, right? So there are different sets also. Like 2024, you will have different sets. Just solve one set, right? And most importantly, eat healthy, because now is not the time to have like any illness or anything, right? You should not feel unwell right now, right? That's what Jassim I'm saying. Yeah, that year has multiple sets, but you have to do only one set, right? Okay, so eat healthy, right? Don't go for junk food at this point of time. Eat very healthy, keep very good care of your health, right? Try to wake up at the time when exam will be held, right? You should be very active. Your mind should be very active in that time range, in that time slot, right? When your exam will be held. So try to practice all these things. Just sit practicing previous year paper in that time slot only when you'll be having your exam, right? And stay calm, because anxiety or this overwhelming experience which you must be having, right? That are not just make your mind learn this thing, that will not give you any result. That will hamper your performance, right? I'm not saying that will not give you any result, but that will hamper your performance somewhere, right? You should be stay calm, right? Do what you can. Just focus on what you can do. Do not focus upon what you cannot do, right? And just start doing it, right? So consistent effort, if you will be putting consistent effort daily, you have to put your efforts, right? And strategic approach you should be keeping, right? So all the best for your exams. So now I'll be sharing you another PPT, right? That in that PPT I have put in like very short paragraphs, some just a compilation I have done of different concepts of this magnetism, right? So just have a quick recap of it. We do not have time in this half an hour to explain everything. Just you'll have a recap of it, right? What all you need to cover, right? All right, and we'll be also looking at the syllabus, right? The exact syllabus we should be having in our mind. All right. So let me share that PPT with you.
So that's why I, went out, right? Telling them that I'm going for an exam, but I went out and I, hid myself at my nanny's place. So, बहुत rebellious kid था मैं उस time पे, right? And I was a very rebellious kid. That is something that I regret. अगर मैं parents की बात सुनता तो life बहुत sorted हो गई. Now let me read my radio friends. Sir, you did not attend askIITians. That's why, sir, we can get into IT just by names. Yes, BSc, MSc, you can do. Sir, first told PW, then askIITians. I'll be honest, everyone. He is the one who started this whole thing, right? This free thing, right? Yes, nobody used to do that before, right? I'll be honest, this is not something that, we should not agree. So if someone has done
See,
something,
so the presentation is visible to you.
सुबह उठकर classes कैसे
Can anyone tell me?
करते थे? What classes?
Yes, sir.
अरे तो we used to go and attend classes with 2 and 3 hours of sleep. So what? But you still do research. I do not get it.
Okay.
So
So you see, so this is from your official CBSE 2024-25, right? So let us have a look at it. So this is the syllabus you have.
They are like, nahi, these are our kids. They
Right.
can never
So
go.
this is from moving charges and
What is
magnetism,
this,
right?
What is this? What is this,
So you see, in moving charges and magnetism, what we have? So concept of magnetic field, Oester's experiment. Sometimes in theoretical question, this Oester's experiment observations also come. Right? You remember that? That this concept of that electric current is having magnetic effects. The magnetic effects of electric current has its foundations in the Oester's experiment. So you must read it, right? There are 3 points that when he increased the current, then the deflection of the galvanometer, then the deflection of the magnetic needle placed near the circuit increases, right? When he reverses the direction of the current, then the magnetic needle points in the different direction. So all these points you must be going through. So this might come in 2 marker, this Oester's experiment, right? Then Biot-Savart law, obviously the definition part, the statement part, right? And with the expression, right? And its application to current carrying circular loop. So this derivation might come, right? This derivation might come. This is very important. This current carrying circular loop, like the one we had in electric field case also, right? So this derivation, so this is the derivation you must write.
I should not have done that.
Right? Then Ampere's law statement, right? Its applications to infinitely long straight wire, this might come. This can also be considered as a kind of derivation, right? For infinitely long straight wire, you have to calculate the magnetic field from Ampere's law, right? that you must be having in your notes. Then we have solenoid. In solenoid, there's no need to learn the derivation of the magnetic field. Only qualitative treatment it is written, right? So solenoid, you just need to remember the formula, which is what B is equal to mu naught and I, right? Then we have force on a moving charge in uniform magnetic and electric fields. That is all about the which force it is known as Lorentz force, right? That force. What is Lorentz force? That it may ask, right? So derivations, if you'll ask me, then the derivation of the magnetic field due to a current carrying circular loop, that comes generally. And with respect to Ampere's law, the derivation with respect to the infinitely long straight wire, right? Then we have force on a current carrying conductor in a uniform magnetic field that I have already told you, right? F is equal to I vector L cross vector B. Then this question always comes: force between two parallel current carrying conductors. And with respect to this concept, right, there is this definition of ampere which comes. So sometimes this also comes. That define ampere, right, with respect to the force between two parallel current carrying conductors. You have this in NCERT. Right? Then we have torque experienced by a current loop that we have seen in a uniform magnetic field. Right? Then current loop as a magnetic dipole. Right? Current loop is a magnetic dipole, right? That we have seen. It is having a magnetic moment, right? I into vector A. And its magnetic dipole moment, what it is, that is all. That is the magnetic moment I into vector A that is talking about. Right? Then moving coil galvanometer, current sensitivity, conversion to ammeter and voltmeter. Right? That is missing. So this part, no, moving coil galvanometer. One question must come. It will come. Right? Conversion to ammeter and voltmeter. One question generally comes. It may be an internal choice, but it will come. Right? Right. All right. Earlier there was cyclotron also, but now it is not there. Right. So derivations, you see definition of ampere, you please learn. Current carrying circular loop, learn. And then infinitely long straight wire with respect to Ampere's law, you learn this. Right?
So यहाँ पे आके मेरे को लगा कि हाँ managers को respect देनी होती है. You have to give your due respect to them because they are more experienced than you and they deserve respect. You have to learn.
Right. Then we have magnetism and matter. So as I've said that in this chapter, we have most important is the bar magnet part. Right. And how bar magnet is an equivalent solenoid, there is no derivation required. Only qualitative, only should be knowing that a bar magnet behaves as a solenoid.
Yes.
Right. Yeah. Then we have magnetic field intensity. This I was talking about, this thing. Right. And here it is written. Here it is written, you need not be worried about its derivation. Only qualitative treatment is required. In the case of electric dipole, you should remember the derivation. But in the case of bar magnet, right, magnetic field is due to a magnetic dipole of bar magnet along its axis or perpendicular to its axis, that means equatorial point. So you only need to remember the formula. Right? So based on this formula, a numerical can come. Right? Then we have torque on a magnetic dipole, bar magnet, uniform magnetic field. Then in that also you need not do the derivation, only the formula. And then the magnetic field lines that I have told you. They might ask you to draw the magnetic field lines and tell you tell the properties of the magnetic field lines. Right? So here bar magnet is important here. And then we have magnetic properties of materials, para, dia, ferro. Right? So you need to tell the magnetic substances with examples, right? These substances. So what are the examples of them? Right? Water, copper, right? What are all these substances, right? Is it copper para? Is it dia? Is it ferro? Right? Then magnetization of materials, right? Here in this magnetization of materials, here we have some terms, like magnetic intensity, right? Magnetization, right? So these important terms you must be knowing the definitions of it, right? And the associated expressions, and then effect of temperature. So effect of temperature. So from these concepts, no, MCQs generally come, right? One marker, right? No, retentivity and coercivity are not there. Not there. It was before, hysteresis curve was before, but now it is not
Really
there.
like the part.
Right.
Enjoy the much, right? Yes. Sir, why do people say ninth grade is harder than 10th grade, but I feel 10th? Yes, ninth grade is easier than 10th grade. People who say ki ninth grade is,
Right.
difficult, I do not agree with them, itna bhi, particularly for math.
Then we have for the
I do not
EMI
know
part,
about
right? In the electromagnetic induction, you see what is electromagnetic induction, it may ask. And then the Faraday's laws, right? What are the Faraday's laws we have? The expression and the statement, right? The induced EMF and the induced current, right? What is the induced current? Induced current would be induced EMF divided by the resistance of the loop, right? Herein, I don't know if motional EMF is also there, no?
Because नहीं यार 8th grade भी मुश्किल है 8th grade भी मुश्किल है
Motional EMF is there or it has been deleted?
बंद करवा दूंगा एक साल में जितनी क्लासेस
It's not written explicitly, but if you know it, you must practice it, right? Motional EMF. Then Lenz's law, statement only, very important, every time comes. And then self and mutual induction, right? Very short topic this is. So let me just have a quick recap of the magnetism part, right? And then we'll conclude the session. If you have any questions, okay, you have done motional EMF before, right? So it comes under this induced EMF only, right? This motional EMF concept. It's easy, right? BVL. Right? What is the induced EMF in? It is BVL, right? This topic I was talking about, motional EMF. All right. So let's move ahead. So you see magnetic field. What is magnetic field? Right? That what is magnetic field? Sometimes in numericals, that's why I have written it. Sometimes in numerical, in MCQs, it might ask that 1 Tesla is equal to how many Gauss? Right? Gauss is the CGS unit of Tesla. So you must remember it is 10 to the power 4. Right? And also in magnetic field, the SI unit is Tesla also, and this Weber per meter square. Right? Acha, you tell me which physical quantity this Weber is of the unit, right? Which physical quantity has this unit Weber?
That their kid will be starting from zero.
Can you tell?
Where they started. But then non-kids will be starting where the
Magnetic flux, right, Jasim? Right? Jasim is only responding. No one else is responding. Why?
So that's very important thing.
All right.
We should all keep it.
Right? Then we have Biot-Savart law. So all these points must be there, right? In Biot-Savart law, all these points must be there.
Right.
Right? These points. If it will ask Biot-Savart law in 3 marker or 2 marker, right?
Yes, you do.
So then you must write all these, that the magnetic field is directly proportional to the current. And if it is directly proportional to the length of the current element, it is directly proportional to the sine theta, right? Sine of the angle between the vector dl and vector r, right? Then it is inversely proportional to the square of the distance, right? And then this formula you should write. This is known as Biot-Savart's law, right? So that's why I have written, I have mentioned it here that these points you should be writing. All right. Right. Then we get this, if we put this constant of proportionality mu naught by 4 pi, you see, we get this mu naught by 4 pi ideal sine theta by r square. Right. So what is this mu naught by 4 pi? This value you should remember, right? This value is 10 to the power minus 7 Tesla meter per ampere. So sometimes they might ask you the dimensions of mu naught. So you should be knowing that these dimensions type of questions come in the MCQs, right? And then many times this question comes that how Biot-Savart's law is analogous to Coulomb's law. So as we have seen in Coulomb's law also, the electric field is inversely proportional to the square of the distance. Similar thing is happening in the Biot-Savart's law. So that you must write. Right? All right. Then I have written this, I mentioned this point that the magnetic field for a straight wire of finite length, I don't know if it is in your syllabus, if your teacher has told you this, but this is a finite length, right? This is not infinitely long wire. So if we have the finite length and this point, we need to find the magnetic field, this is the current, and this angle is alpha, this angle is beta, and this is the formula you have. And these distances are, this is the perpendicular distance you have. Right? It's not in the CBSE syllabus. All right, all right. So let's leave it then. Then this point I was telling. This derivation you must be knowing. Derivation you should be knowing. This, you leave this. This one I'm saying. Right? It's derivation you should learn.
So this one 8th grade guy.
In 5 marker, this might come. Right? That how to find the magnetic field due to a circular current carrying loop, and it has this expression.
Yes, so you said,
Right.
sir, I want prediction reason that I have something in my backbone, right? Yes, so I do not understand what was the problem.
All right. Then there is this concept of magnetic field at the center of a current carrying loop. Right? Previously, we were having on the axis. So it is from the center at a distance r. I want to calculate the magnetic field. Now, if I want to calculate the magnetic field at the center, what I'll put? I'll put r is equal to 0 here. And when I'll put r is equal to 0 here, what we'll get? We'll get this formula, mu naught I by 2r. Right? And how to calculate the direction? Right hand thumb rule. Okay, curl the fingers on the direction of the current. The direction of the thumb will give you the direction of the magnetic field. Right? And if this coil is having number of turns as n, then this magnetic field at the center, you just need to multiply it by n, mu naught ni by 2y. Right? Then you have to know the statement of the Ampere circuital law. Right? Draw the diagram also. Right? So this is the mathematical expression, and you must write down the statement also. So it might come in 1 marker or 2 marker. Right?
Even next day, what you're going to do, you should have a plan. You should have a plan of a month.
The magnetic field of solenoid that I have told you need not know the derivation. Just this formula you should remember, mu naught ni. What is small n here? Can you tell me? Is it the number of turns? What it is?
I've never been disappointed.
Is it the number of turns?
You know, ये नहीं मिला. मैं बहुत disappointed होता हूँ कभी-कभी जैसे.
It is the number of turns per unit length. Good Aditi. Good Jasim. Yes, good Janam. Right. So it is number of turns per unit length. All right. Then we have force on a moving charge in a uniform magnetic field, right? So this formula F vector F is equal to Q vector V cross vector B. Right. So what is the maximum force that would be possible? So maximum force is possible when theta becomes 90 degree. That means the velocity and the magnetic field becomes perpendicular. Right. So in that case, the force will be QVB. Right. So you see this circular motion it will have. And what is the value of this R here? MV by QB that we have written. Right. Then we have this concept of helical motion. Can you tell me helical motion is there or not? I think it is there, right?
But
yes, it is there, right? So helical motion is there. So when it happens, when velocity is not perpendicular to the magnetic field, one component is, you see, this is the magnetic field in this direction on the x-axis, and this is the velocity vector. So one component of the velocity is along the magnetic field, one is perpendicular to it. So the perpendicular component of the velocity will make the charged particle go round and round in the circular path. And what this parallel component will do, it will move this charged particle along the magnetic field so that it will have a helical motion. Right? What is the pitch? Pitch is what? So this definition of pitch, they might ask you. Right? What is the pitch? The horizontal distance or the distance along the magnetic field which the charged particle travels while completing one circular motion, while completing one circular path is known as the pitch. Right? So what we do here, you see, so this is the radius of the circular path here. Here also the formula is mv by qb, but in v we only put the value of v perpendicular, the perpendicular component's value, because it is only responsible for the circular path. Right? So this formula is important. Right? Then we have the time periods formula. What is the time period now? Time period is 2 pi r, right? 2 pi r by the velocity. And by which velocity it is moving? By which velocity it is moving? It is moving with the velocity v perpendicular only. Right? This is the formula for the time period in general. And if we want to find with respect to the helical motion, then we'll have to put this v as v perpendicular, but v gets cancelled out. So the time period always has a constant value, is independent of the velocity, that is 2 pi m by qb. Right? This is time period formula is important. Then this radius, you see, I am just marking some formula here. So this formula you must be knowing. This formula you must be knowing. Here what I have done, Here, this momentum has been put in the form of kinetic energy. Momentum is equal to under root 2 m k is the kinetic energy, right? So this way also the equation can be uh, this equation can be written, right? Then we have frequency. Frequency is what, 1 by t. So you reverse it, reciprocal it. What is omega, right? So all these things you must be knowing. Got it? All right. Then we have pitch. So what is pitch? Pitch is V parallel to the time period. So this is the formula you must remember. Right. So what is pitch? The definition of it, the distance moved along the magnetic field in one rotation is called pitch, and the this expression. Then you must be knowing the Lorentz force. It might ask you in one marker what is Lorentz force, right? So you must be knowing that it is force on a moving charged particle when both fields are there, magnetic and electric field, both are there. And this expression you must write, right? Okay. Then we have force on a current carrying conductor. You see, we have F is equal to I vector L cross vector B. Right, this thing I was telling you. What is the maximum force? Maximum force is when the angle between vector and vector B comes out to be 90 degrees. So when they are perpendicular, right? So in that case, the force would be maximum IVA, right? Then we have force between two parallel current carrying conductors. This I was telling you that this sometimes comes, right? This becomes important many times, right? Many times the questions are asked from it. So you must be knowing that how we get to this expression. Getting it? Force between two parallel current carrying conductors. Right? Then torque. And torque I have told you it is vector M cross vector B. And if the magnetic moment I am calculating of a loop having current, and the loop is having n turns, then the magnetic moment becomes what? NIA. Right? And what is the total torque that will become? Because it is MB sine theta, right? So it will become MB sine theta, M cross vector B. So M is NIA. So NIAB sine theta it will become. Right, got it? Right. Then we have about the moving coil galvanometer. In moving coil galvanometer, you should be knowing this. So I am just having, you just have to have a quick recap of it, right? So for you to revise later on, right? If today only you will revise it, you will have fresh in your memory, right? And you will be able to revise 3 chapters once, right? So moving coil galvanometer, you see. So in moving coil galvanometer, what is current sensitivity? You must be knowing, right? Then this expression, if you already know, you can learn it now. But if you don't know, just leave it for now, right? You should know the current sensitivity definition. What is current sensitivity? It is the deflection per unit current flowing through it, right? So this definition you must be knowing, and this expression you must be knowing. And what is the unit of it? It is radian per ampere, because theta is in radian, I is in ampere, or division per ampere also, because theta we generally denote by the division, right? What is voltage sensitivity also you may learn, right? But in the syllabus it is in current sensitivity, so you might learn about the voltage sensitivity also. Then this is important, conversion of galvanometer into ammeter. So in ammeter, what we do? We put a shunt resistance, right, in parallel. In parallel to the galvanometer, we put a shunt resistance, which is a very small resistance we put. Shunt is a low resistance, which is connected in parallel to the galvanometer, right? So this formula you should be knowing, right? How to arrive at it. So this concept of moving coil galvanometer, make conversion concept. That is important. Conversion to ammeter, conversion to voltmeter. 3 marker, numerical might come, right? And then in converting to voltmeter, we put a high resistance in parallel. Sorry, in series. We put a high resistance in series with the galvanometer, high resistance connected in series with the galvanometer in the case of converting to voltmeter. And the associated expression you must be remembering, right? Then I don't know if still it is in syllabus, but many times this question also be asked, that magnetic dipole moment of a revolving electron, right? If only an electron is revolving in a circle, right? So an electron revolving also constitutes current. Even it is one electron, but it is moving. So that is the flow of charge. So current is there. So current is there, so magnetic moment must be there, right? So what is the current here? Current is the charge on the electron upon the time period. And what is the time period? What is the time period? Time period is 2 pi r, the circumference it is covering, the distance it is covering upon the speed of the electron, 2 pi r by v. So that is how we calculate the current. Current comes out to be EV by 2 pi r. And then what we do? Same, I into A. The magnetic moment is I into A. Current we have calculated, and A is pi r square, obviously, because the circular path that is moving in has a radius r. Right? So magnetic moment comes out to be EVR by 2. Many times this derivation comes. So that's why I have put it to this presentation. Right? Then you see, then this magnetic dipole from the next chapter, magnetism and matter. So herein, this we have, right? What is so the magnetic moment is where from south to north, right? Magnetic moment is from south to north. Magnetic dipole moment, the direction in the case of a bar magnet, right? So similarly, it is having this minus m plus m represents the pole strength, right? Pole strength, one of the pole strengths, and the distance between the poles, 2L. That is the magnetic dipole moment as defined in the case of electric dipole, right? Okay. Then these formula I was telling about. So this is bar magnet, and you need to calculate the magnetic field at this point. This is the axial point, right? So it is this formula. But it is for which? It is for what? It is for when the D is very much greater than this L. When D is very much greater than the L. Only that you need to remember. Right? And this is the equatorial axis, equatorial point we have. So this D is very much greater than. So these formulae are for when D is very much greater than L. When D is very much greater than L, only then these formula apply. You see, similar type of formula we have. In terms of electric field, we have K 2P by R cube. And in the case of equatorial, we have E K P by R cube. Like you see, same. This is like K, M is like P, and this is D is like R. So same kind of, this is analogy you should be noticing, right? Okay. So then this I mentioned separately, that oscillations of freely suspended magnet, this question sometimes comes. That was the time period of it. So moment of inertia upon MB. So this concept, if you have not done the revision of it, right, it is related to SHM. If you have not done revision of it, do revise it, right? Sometimes question might come from it, right? How many of you people know it? The oscillations of a freely suspended magnet. Have you done it? The time period of it. All right.
Okay, so
Okay.
you are
Then potential energy also sometimes come, like the way we have minus vector P dot vector E. Similarly, we have here minus vector M dot vector B, minus MB cos theta. Right? Stable equilibrium, unstable equilibrium, same thing. Right? Then magnetism and Gauss law also sometimes comes. Right? This concept that the magnetic flux through a closed surface, right? Magnetic flux through a closed surface, as we have in the case of Gauss law, is always zero, right? So this thing sometimes comes. So you just note it down, right? If you have not done it yet. Then magnetic properties, that this I was saying, that magnetic intensity, what it is B naught by mu naught, right? This H, what is intensity of magnetization, what is magnetic induction, right? Mu naught H plus I. So what all these terms are, you should be knowing that. What is magnetic susceptibility? What is magnetic permeability, right? Then what is relative magnetic permeability, right? And most importantly, this thing, relation between mu r and susceptibility.
competing with you.
So this expression should be in your mind. Mu r is equal to 1 plus chi m. MCQ might come, right? MCQ always comes, right? And mu r is dimensionless quantity. Chi m is dimensionless quantity. That you must be knowing, right? And this thing you must be knowing. This is written here. Value of magnetic susceptibility is small and positive for paramagnetic. So for paramagnetic, the value of chi, it is known as chi m. Chi. So the value of chi, right, susceptibility for paramagnetic is small and positive. For diamagnetic, it is small and negative, right? Then what is diamagnetism? You should be knowing, right? What is paramagnetism? You should be knowing, and these diagrams. So diamagnetic substances are those which have a tendency to move from stronger to weaker part of the So they're repelled, right? So when a bar of diamagnetic material is placed in an external magnetic field, it is repelled,
Like
right? And paramagnetism, it is weakly attracted. So both are weak, but here repulsion is there, here attraction is there. So explanation is also there, right? You must have learned about the explanations of why it is happening in diamagnetic substances, what is happening in paramagnetism, right? Then this is Curie's law, right? That you must be knowing. Right? Curie's law. Then what is ferromagnetism, right? So that you must be knowing, and how this and the explanation of ferromagnetism, right? The concept of domains, right? We have a concept of domains in ferromagnetism, that concept we must be having. And the Curie temperature, that it is the temperature at which ferromagnetic turns into paramagnetic, right? Right. So that's all we have for today, right? So I advise you to write a please just I have made a I have given you a process, right? So you should be now revising all these concepts, right? And be very thorough with them, right? The electromagnetic induction also, you please cover it, right? In this way. So from your class notes, do revise, right? And do keep practicing your previous year papers now, right? So we'll be having our next session, I think on Thursday next week, and it will be of the remaining chapters, right? It will be of the, I think, optics. We have left optics and this AC and electromagnetic waves, right? So that will be covering. In that, optical instruments I'll be focusing upon. Sometimes people, students face problems in optical instruments, right? So that I'll be covering in that. And so I think you need to keep practicing and have a quick so this quick reason this quick revision might have benefited you, right? And so my advice is to today only, right now only, right after taking a break or something, so you should revise these three chapters, right? Okay. Thanks a lot. You may please leave the session now, right? And if you have any question, I am here taking your questions, right? If you have any questions, you can ask. Thank you, Justin. Thanks a lot.
Badly, very badly you studied. Or very hard you studied. Huh?
Yeah, thank you, Sanika.
Achha.
Thank you, Vijay Sarthi.
Okay.
Thank you, Aditi. Yeah, thank you, Janam. Thank you. Thank you, Vania.
Okay.
Yeah. Bye. Bye.
Okay. So